Good morning, friends and dear students. It gives me immense pleasure to be here again for my course, Flight Mechanics. Today I am going to discuss about fuel safety on aircraft, and I am Dr. Yagya Dutta Dwivedi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. Today's overviews are fuel planning, taxi and the trip fuel, in-flight fuel management, procedure if fuel is less, dumping of fuel and the tank location, fuel calculation, flight planning. First, I will discuss about the fuel planning, fuel and flight planning definition. First, we will discuss additional fuel. Additional fuel is the fuel which is added to the comply with a specific regulatory or the company requirement. Alternate fuel is the amount of fuel required from the missed approach point at the destination aerodrome until landing at the alternate aerodrome. This takes into account the required fuel for missed approach at the destination airport, climb to en route altitude, cruise and descent at alternate aerodrome. So, what is the meaning of alternate fuel? If you are flying from the A airport and you want to reach to the B, due to some mistake or due to some problem at the B where you are supposed to land, this ATC of that airport will direct you to go to the nearest airport. Like if it is Hyderabad, you can go to the Begumpet, you can go to Dundigal, you can go to Hakimpet. However, this Hakimpet and Dundigals they are the defense airport. So, first preference they will give to the Begumpet. Begumpet is very near. It will not take much fuel. But sometimes if Begumpet is not working, or it is some small city where you have only one runway and you have to go some other places, that time this alternate fuel is procured inside the aircraft. Always it is kept inside to cater for the missed approach at the destination airport, climb to en route altitude, cruise and the descent at alternate aerodrome, approach at alternate, landing at the alternate aerodrome. Next is the ballast fuel. This ballast fuel is to balance the aircraft. We should able to make the center of gravity. If sometimes the weight is more in one side, so we will consume more fuel on that side where weight is more. So your aircraft is balanced. So ballast fuel is sometimes carried to maintain the aircraft center of gravity within the limits. Next is the contingency fuel or the route reserve. Contingency fuel is carried to account for additional en route fuel consumption caused by wind, routing changes. According to ICAO Annex 6, the recommended minimum contingency fuel is the greater of 5% of that trip fuel or 5 minutes holding consumption at 1500 feet above the destination airfield. So, this contingency fuel is used for catering the wind situation, routing change. So, according to this ICAO regulations, 5% of the extra fuel has to be carried by the aircraft. Final reserve, fixed reserve fuel, holding fuel. Final reserve fuel is the minimum fuel required to fly for 30 minutes at 1500 above the alternate aerodrome, or if an alternate is not required at the destination aerodrome at holding speed in ISA condition. Some regulating authorities require sufficient fuel to hold for 45 minutes. But some bigger aircraft, they have to keep the flight for 45 minutes. This holding fuel to hold above the runway, above some given area, it should be able to fly. Next is the taxi and the trip fuel. Taxi means on the ground when aircraft is moving from runway to the dispersal to the hangar. This they need some fuel to use for the engine. So that fuel is called the taxi fuel, and the taxi fuel is the fuel used prior to takeoff and will normally include pre-start APU, that is the auxiliary power unit consumption, engine start, and the taxi fuel. Taxi fuel is usually a fixed quantity for an average taxi duration. However, local condition at the departure aerodrome should be taken into consideration and the taxi fuel adjusted accordingly. Trip fuel, burn fuel, and the fuel to destination. The trip fuel is the required fuel quantity from brake release on takeoff at the destination, departure aerodrome to the landing, touchdown at the destination aerodrome. This quantity includes the fuel required for. Trip means from one location to another location. How much actually fuel is consumed? That is called the trip fuel. What is actually burned? That is called the burn fuel. That is used for the destination. So the trip fuel is the required fuel quantity from brake release. So if the aircraft is here and you release the brake for the takeoff, from there to the landing of that next destination, takeoff at the departure aerodrome to the landing touchdown at the destination airport. So if it is the runway and your aircraft is touched down here, how much fuel is required from this to this? That is called the trip fuel. Now the takeoff, climb to cruise level, flight in level cruise including any planned step, climb or steep descent, flight from the beginning of the descent to the beginning of the approach landing at the destination. We have the flight management for the fuel. In this we will see the first one is the monitor. The pilot will monitor from the cockpit. He will see that how much fuel consumption is there, it is as per the required or not. Then pilot will analyze how much fuel is required to reach to the destination. If any emergency, is it okay or not? Then pilot will formulate these. Then if required, he will modify the route so that there should not be any emergency, and in this way the flight management system is working. It is shown here the process steps for in-flight fuel management system. Procedure if fuel below a specified level. So if the fuel is below the level, then step 1, identify and communication of the fuel states. Step 2, in-flight fuel check value less than the planned value, not less than required. Step 3, expected fuel remaining is approaching minimum value. Step 4, minimum fuel state. Step 5, emergency fuel situation. Mayday, mayday, mayday will be announced by the system, and if any aircraft or any runway or airport or any ship is there, they will detect this signal and they will take the necessary action. Dumping of fuel and the tank location. We have to store that fuel. So dumping of the fuel. If you see here, the aircraft is carrying a huge amount of fuel, and during landing especially and the takeoff or during the flight, if they feel that aircraft is getting imbalance, that time they have to dump the fuel. Or if they feel that there is a fire in one side of the engine, so nearby fuel tank has to be ejected. Fuel has to be ejected. This is called the dumping of the fuel. Fuel tank arrangement. This you can see here. This is your fuselage. These are the wings. This is the tail. All this pink color is stored on the wing. This is at the belly below your fuselage, and here, and if you see here, vent tank, trim tank, vent tanks are also fitted on the horizontal tail. So here we have the outer tank, here is the inner tank, here is the vent tank. Here also you have the inner tank, outer tank, vent tank. This all fuel is stored, and as per the requirement, if everything is balanced, all the fuel will come together slowly, so that the center of gravity of the aircraft is maintained, and aircraft will maintain a nice balance, and there should not be any chances of the fire, there should not be any chances of the leak. Tanks are made in such a material that any case of the bullet damage, the hole are self-healed, and these holes are covered due to the heat of the bullet, and it is pasted. It is like a glue is pasted on this tank, and the leak is prevented. Fuel calculation. Each person computing full fuel for the purpose of this subpart shall consider the following: wind and other weather condition forecast, anticipated traffic delay, one instrument approach and the possible missed approach at the destination, any other condition that may delay the landing of the aircraft. Legal fuel requirement. Taxi fuel standard figure as quoted in the aircraft handbook. Trip fuel from takeoff at departure airfield to the landing at the destination airfield. Contingency fuel is a 5% of the trip fuel or 5 minutes, whichever is the greater. Alternate fuel, fuel to farthest alternate airport where your aircraft is supposed to land. Final reserve is the 30 minutes for turbine aircraft and 45 minutes for the piston aircraft. This is called the fuel reserve. Now we will talk about the drop tank. A drop tank, external tank, wing tank or the belly tank is used to describe auxiliary fuel tanks externally carried by the aircraft. A drop tank is expendable and often capable of being jettisoned. External tanks are commonplace on the modern military aircraft and occasionally found in civil one, although the better or less likely be discarded except in an emergency. So if you see here in this aircraft, this is your drop tank. These drop tanks are fixed so that if you want to go for high range, this fuel will be used. After using this fuel, you may jettison this tank. You just drop this tank if required. If you don't want, you can come back again. But mostly in the fighter aircraft, if you see the fighter aircraft here, these are the drop tanks here. These drop tanks are used to extend its range. Suppose without drop tanks, the aircraft goes for 2000 miles. But if you fix this thing, 500 miles, it will increase. So attack range will be increased. However, the load carrying, the ammunition or the missile carrying capacity of the aircraft will be reduced. However, if the range is important, we will fix this drop tanks below the wing and you fly it. As and when these fuels are consumed, then it will be dropped and then aircraft will further go ahead and it will do the mission and it will come back as the required. Flight planning. Flight planning is the process of producing a flight plan to describe a proposed aircraft flight. It involves two safety critical aspects, that is fuel calculation to ensure that the aircraft can safely reach the destination and compliances with air traffic control requirement to minimize the risk of mid-air collision. Flight planners normally wish to minimize flight cost through the appropriate choice of route, height and speed, and by loading the minimum necessary fuel on board. Fuel tankering. Fuel price variation in each location and absence of fuel or contractual restrictions with suppliers along with the routes may result in transporting more fuel than the minimum required by the regulations from certain locations so as to minimize supply cost. The practice of carrying an extra quantity of fuel is called the fuel tankering or economic supply. So what is the fuel tankering? We will carry some extra fuel. If some place the cost of the fuel is high, so we will not take fuel from there, but we will take from the original place where the cost of fuel is less. So in this way, we can make sure that the cost of the flying is reduced and the most economical supply of the fuel is obtained. So here for the example, in Brazil, fuel tankering is a very common practice as there is a large variation in the tax rate on aviation fuel amongst the states. A variation of between 4 to 25% is expected from state to state. Fuel tankering is basically carrying more than you need. Aircraft will do this for a number of reasons. The main one that I can think of are higher fuel cost at the next stop, availability of fuel at the next stop, faster turn time. Fuel, a big issue on aircraft operation because most of the flight costing is fuel. A huge amount of fuel is consumed by the aircraft, so we have to take care of this fuel in the aircraft. To earn money, an airline company need to have their aircraft up in the air as much as possible. The problem is that fuel is very expensive and it keeps getting more expensive every day. There are a lot of things you can do to lower the fuel consumption. For example, aircraft fuel efficiency. Reducing the payload, that is fuel also weight, so you only refuel the amount of fuel that is needed for the trip and for the alternate departure airport. Optimize the flight routes, regular aircraft maintenance, fuel tankering. These are the process by which you can reduce the fuel cost. Fuel tankering is a way to lower the fuel cost by buying the extra fuel in other countries where the fuel is cheaper. You may think that if the fuel is cheaper at the arrival country, you can just refuel as much as possible. Unfortunately, it is not that easy. Risk with the fuel tankering. Cold soaked wing is a phenomena where ice will form on the wing even though the air temperature can be well above the 0 degree. If you are flying on a high altitude for a long period of time where the air temperature is below 0, the temperature of the fuel in the wing can get into below 0, which will also be the wing surface temperature below 0. When descending, if the wings come in contact with the liquid water such as condensation or the rain, the wing will begin to freeze. This is called the wing freezing. The effect can have serious consequences because it can reduce the speed to such a degree that the aircraft cannot even reach the minimum speed for takeoff or maintain flight. If you get cold soaked wings, you will need to de-ice your aircraft. De-icing means that you are warming up the fuel in the wings to above 0 to prevent ice from forming on the wing. This can take a long time and can get the aircraft to be delayed for next flight and money is lost. Profit diagram of a Boeing 737 with different routes. If you see here that profit is increasing if you are flying at 330 nautical miles and it is reducing if you are flying a more distance. So a required distance is good to fly with a very optimal rate, different profit. You cannot go, if you are going very high or long distance by the one aircraft, the cost of the fuel will be high. Fuel tankering process, here we have the input data, we have the performance calculation, a small computer, intermediate results, fuel tankering module, final result, it will queue to the feedback here, adjust amount of extra fuel, a block diagram illustrating the fuel tankering process. Some abbreviation we have to use for our aircraft. That is, first one is NOTAM, Notice to Airmen, messages created and transmitted by government agencies and airport operators to alert pilot of any hazards. So these NOTAMs are released by different countries. If the countries are firing the missile or doing any testing on the space, they will issue the NOTAM so that no other aircraft will be in that area where you are doing some testing. MTOM is a maximum takeoff mass, the highest mass allowed for an airplane to take off on an airport. ATOM, actual takeoff mass, the actual mass of the airplane when taking off. MLM, that is a maximum landing mass, the highest mass allowed for an airplane to land on an airport runway. ALM is the actual landing mass, the actual mass of the airplane allowed when landing on an airport runway. Leg, a route between two airports is called the leg. Trip kit, a document that is handed to the pilot that contains all the information for a certain flight. So these are the few very important abbreviations which are used for aircraft operation. Fuel tankering management, this is the some tankering systems are here. So in the next we will be discussing about some problem solving and all. So thank you very much for this, and these are the references. Anderson JDGR, Aircraft Performance and Design, International Edition, McGraw Hills, first edition 1999. SL by ME, Aircraft Performance, Theory and Practice, AIA Education Series, AIA 2. Any questions, you are welcome to ask to my email. My email is ydwivedi@gmail.com. Please do like and subscribe this channel. Don't forget to hit the bell icon which is present in your YouTube channel. Please do comments, write the comments if anywhere you have any problem. Thank you very much for the joining. Okay, goodbye. See you.
Like, share and subscribe. Hit the bell icon for more updates.